Welcome to this session on real-world gaming. So my name is Clementine Jacoby, and I'm a product manager on Google Maps. I'm actually based out of Sydney, Australia, which is where Google Maps was born 13 years ago. But today I'm going to be talking about real-world gaming. So first I'm going to start with a little bit of history. For those of you who know maps really well, you can just take a quick power nap. But after that, I'll show you some of how mobile developers are using location data to create immersive experiences. And then I'll dive into how you can get started building games with real-world data. So let's dive in. Google Maps has been building and understanding and expanding a deep understanding of the world since 2004. And since 2005, we've been making pieces of that model available to developers like you. In fact, the Maps API was one of Google's first APIs ever. So over the last 13 years, our model of the world has evolved from providing static maps to dynamic maps to then location intelligence. For those of you who saw Gayathri's keynote yesterday, location intelligence means delivering a rich, relevant, real-time context about the world around the user. And through location intelligence, developers are bringing elements of the real world into their applications. At the same time, they're bringing their applications into the real world by augmenting the world around their users with digital content. As the augmented reality, or AR, revolution begins to take shape, we at Google Maps are seeing information, imagery, and animations from mobile services superimposed on the real world. Developers can now annotate real-world media to help people find places faster, or make informed decisions, or just have fun. AR is enabled by two key trends. The first one is that super powerful mobile devices are becoming more and more prevalent and integrated into daily life. The second is that advancing technology, things like location precision, now allow us to place digital objects in our real environment with increasing accuracy. So this goal of informing and orienting and delighting users at a glance is now closer than it's ever been. So how did we get here? The first thing is a good model. So over the last 13 years, we've improved our model of the world by adding, again, more digital, dynamic, and real-time content. The second piece is better technology. In those 13 years that we've spent improving our model, technology has also gotten better. And over time, combining this accurate model with improving technology has opened up new use cases for real-world information. This has led to really big changes in how maps are displayed and used. So let's look at this progression. For hundreds of years, we used paper maps to navigate. And then just 20 years ago, Ajax brought maps to the digital world. This enabled the first ever Google Maps product, a map that could be explored in your web browser. We designed our first directions offering to help these desktop users plan their journeys ahead of time. But then, the mobile era ushered in this huge paradigm shift for maps. So suddenly, users were out walking around with their phones, and they expected us to tell them where to go. They needed more than just digital maps. They needed dynamic maps that adjusted as they moved through the world with their smartphone in hand. So as mobile took center stage and adoption rates grew, demand shifted away from route planning, and demand for on-the-go navigation surged. As users came to rely on us for directions, they did so even when they were driving or biking. So we had to adapt our offering to determine the best path no matter how you were traveling. To do this, we needed to learn way, way more about real-world dynamics, like how was the traffic, were there accidents along the route, what were the public transit schedules. And we made all of this dynamic information available via our Directions API so that it could be used by third-party applications. Drivers were then able to use that Directions API to optimize their routes around passenger demand, and as location data became more precise, ride-sharing apps started to flourish. Then, with the advent of big data and machine learning, we were able to move again from dynamic maps to real-time location data. We now take an ever-increasing number of these real-time signals into account to provide our users and a huge range of third-party applications with a more nuanced and intelligent model of the world. For example, rich and reliable data, coupled with powerful machine learning algorithms, allow us to help drivers route around real-time traffic. And as of recently, and I think this one is very cool for everyone who's from San Francisco, with the help of machine learning, we can let you know if it will be difficult to park at your destination right now. So as mentioned, the canvas for all of this real-time information is our model of the world. Advancing technology has enabled us to go beyond the digital to dynamic to real-time information. Meanwhile, that underlying model of the world has become more sophisticated, and it can now supply these real-time services with all the detail that a developer or our algorithms need to make intelligent suggestions. So let's look at how that underlying model has evolved to support new use cases. Our very first product, that web-based digital map, used 2D imagery. We expanded on that product and included things like 3D buildings and elevation models and terrain. And then, to usher in the mobile era, we turned our attention to helping users navigate urban environments while on the go. Places play a really big role here. Understanding cities is sort of an obsession for Google Maps. Our maps now surface tons of detail about real-world places to help users orient themselves, but also to explore. So one of my favorite Google Maps products is the corridor. When I'm in a new city, I like to know that one block over from me, there are tons of shops and restaurants. And I'm happy to walk a block or two out of my way to go down a street that's hopping. And corridors let you do that. Our Places API is this amazing resource that makes details like this, about 100 million points of interest across the globe, available to developers. And just like our other services, the Places API is constantly bringing in more and more dynamic and real-time information sources, things like businesses' open hours and ratings and reviews. And then finally, it turns out that a lot of users like me get lost indoors, especially. So today, Google Maps can even help you explore inside of places like shopping malls and airports. This is a perfect example, by the way, of advancing technology like indoor GPS and an improved model of the world like indoor maps combining to create a new use case for maps in the wild. OK, let's look at one more example of a user experience where I think our underlying data model really shines, going out to dinner. So today, Google Maps can help you find a restaurant based on its location, ratings, and reviews, read the menu, check how busy it will be now and later tonight, book a table, and hail a ride, all from Google Maps. And to make this possible, we had to bring together many different signals about movement in the real world, including how cars, trains, and crowds are moving. So this is what it looks like when you bring this all together. At the bottom, you've got technology steadily marching along, improving and raising the bar for developers. And then riding that wave, you have this increasingly sophisticated model of the world, with more and more real-time information about the global environment. And when we put them together, new possibilities emerge. Services that ingest this model become more relevant and intelligent. And critically, those same services could be what power your next game. So how are developers like you using this model of the world in your applications? Well, at Google, we're seeing a big shift in demand from dynamic mapping solutions like directions and place search to location intelligence. What is location intelligence? So it goes beyond the map. Location intelligence is about bringing together everything we know about the world around the user, about the context around the user, and then delivering insights when they're useful. Location intelligence, for example, allows us to go beyond knowing that there's a bus stop near you, to knowing the timetable for that bus stop, to knowing how close the next bus actually is. Or it means, not just telling you that there's a taco shop a block away, but actually going a step further to tell you that the tacos are cheap because we know you like cheap, and that the shop is open now, and that it's not even that crowded, and that the reviews are fantastic. Understanding your user's constantly changing environment is key to building experiences that are relevant and personal. Personally, any taco near me is a taco that I want to know about. But that level of detail might be annoying or bizarre or just irrelevant for someone else. So location intelligence, it's powerful for developers because it allows you to build relevant and rich experiences that cut across industries, and in some cases even create new ones. For example, ride sharing. Not long ago, we stood on street corners and hailed cabs. No location intelligence involved. But now, we request a car that arrives in moments. It's chosen based on its proximity to you. And as it arrives, we watch its approach in our app, in real time. Your driver shows up already knowing your desired destination, and all of this is context, specific to an individual user. This is location intelligence at work. It's an experience, and in this case, it's a whole industry that just couldn't have existed without location data. I promise I'm getting to gaming. So in other cases, we see location intelligence enhancing existing industries, apps, or services. Mobile services leverage location data to build experiences that aren't really about maps, but they're tied to or fueled by or mixed with the real world. One simple but very powerful example of this is the check-in. So in basic terms, what is the check-in, right? It's just a way of recording a real-world action. But the applications of the check-in have proven expansive. You can check in to let your friends know where you are. You can check in to get a deal at a real store. You can check in to enter a contest or rise on a leaderboard. And actually, the leaderboard piece is interesting because it demonstrates that a simple use of location data is also a way of turning an everyday action into a game. A game you might win by rising on the leaderboard, or getting from point A to point B quickly, or unlocking a special treasure at an obscure location. So what we've noticed at Maps is that integrating location into your mobile service often turns that experience into a game. Look at exercise. Exercise has proven itself ripe for gamification. Tons of developers are using location to augment their apps and services in exercise. Today, you can use apps to track your workouts, compete with friends, log miles, earn trophies. Top brands are using location data to gamify exercise. Points and milestones and competitions are helping users get fit, clear hurdles, stay motivated. And critically, as developers use gamification to help users achieve their goals, users respond by spending more time in the app. So gamification leads to engagement. In our API business, we see brands competing to make their apps more involving and immersive and compelling by bringing in more and more location intelligence. They're using location to motivate and to encourage competition and to engage their users. And as that happens, the very definition of a game has already begun to blur. Lots of real-world experiences lend themselves well to gamification, and I'm sure you've all seen it in your industries. We definitely have. Exploring a city is kind of like a quest where you have to unlock certain skills to achieve milestones. Finding a good meal is always an adventure. So is trying to navigate traffic with insider tips based on real-time traffic jams. But these are all implicit games, and what we're starting to see now is that developers are making these game-like aspects explicit. So we've talked about two trends, and they're unfolding really in parallel. First, as I illustrated earlier, as devices improve and our model of the world becomes more nuanced and precise, developers are suddenly able to augment the world with digital content in ways that just weren't possible before. And secondly, as powerful devices become more and more integrated into life, standards for what constitutes an engaging mobile experience just keep rising. This is causing a shift that's bringing routine tasks and fun closer together through gamification. And game developers find themselves right at the nexus point of these two trends. And boy, are game developers rising to the occasion. So let's look at an example of a developer, a game developer, using location data, powerful smartphone penetration, and innovative technology to create a phenomenon that would not have been possible a few years ago. Last year, we saw real-world gaming go mainstream overnight. On July 5th, a company named Niantic launched Pokemon Go. And by the morning of July 6th, people of all ages were outside, walking around, collecting virtual Pokemon. This game was different from any that had come before, and you could see it on the streets. But real-world gaming is not a new idea. We've been building games based on real-world discovery for a long time. Think of geocaching or scavenger hunts or Niantic's first game that they built within Google, Ingress. But the difference now is that mobile phones are advanced enough and ubiquitous enough that real-world games have a massive potential market with all of the technology that they need to play in their pockets. The difference now is that our model of the world is so detailed that it can be used to build experiences that leverage this complexity and dynamism in ways that weren't possible before. So we're arriving in a place where it's possible to augment the world with mobile content and to augment mobile experiences with real-world content. And this just raises the bar again for what highly engaged users will soon demand. The colossal growth of Pokemon Go confirmed that we've arrived at an inflection point, a time when a sophisticated model of the real world, combined with powerful IP and an unprecedented game mechanic, can be leveraged by smartphones to blend mobile experiences with the real world. The launch of Pokemon Go was a global phenomenon not only for its unique gaming experience, but also because of its explosive growth. Niantic and engineers from Google Cloud worked together to scale to 50 times Niantic's forecasted traffic to accommodate their unexpected popularity at launch. Niantic set out to create a different kind of gaming experience as well, one that got participants off of their couch and into the real world. They leveraged Google Maps, among other sources, to create a truly iconic augmented reality game. So let's take a closer look at some of the technologies and data that are used by real-world games. This is not specific to any particular game, and the details will vary depending on what you're trying to build. But at a high level, these are some of the features you'll need. First, precise user location. Location precision has improved dramatically in the last couple of years, and it continues to. It's now possible to tell not just what city block you're on, but what store you're in front of, and even what you're looking at, or what direction you're facing. And for developers, this means a more fine-grained understanding of exactly where their users are in relation to in-game objects. Real-world games can leverage recent improvements in location precision to pinpoint exactly where its players are, and in some cases, what they're looking at. Next, base maps. To build a real-world game, you need a map that reflects the real world. You need the geometry that defines roads and paths that users walk along. You need polygons that define the building footprints around them. You need the outlines of parks and lakes and fields and the metadata that helps you actually distinguish between those things. You don't want to place objects in the middle of a large body of water because you thought it was a park, or style a lake the same way you would style a park. In a real-world game, a styled base map is your game level. And there are lots of choices for the developer and the artist to make. What level of visual interest do you want on the map? Where do you want to focus your user's attention? For example, you might use a full 3D building model to create an immersive experience, or instead you could use simple building footprints to orient users without overwhelming them with visual detail. There are a lot of ways to use geometry and the metadata of map features to determine how to style a game world. And you can also use the base map to design gameplay. And this is a bit different. So here, you might use the type of an area to determine what kind of game object would be collected there. For example, you could use a map to determine where the forests are and allow users to go there to collect wood. Finally, global scale. With Google Maps, a global rollout of a game can take place seamlessly, because you can leverage the infinite variation of the real world to make your game nuanced and interesting no matter where it's being played. So let's focus on just the maps piece. How could you use our maps to create a real-world game? At a very, very high level, it looks like this. First, you request map tiles from Google Maps. Then you filter out the data that isn't critical to your game. So for example, maybe you don't care about road labels or road shields or cycling lanes because you expect all your users to be walking. Next, you would style the map to suit the look and feel of your game. For example, you could make pedestrian paths and boardwalks and beaches really broad and visually dominant, and you could de-emphasize highways and freeways and other places that you didn't want to encourage your users to walk. You can apply your own styling to any area on the map, using the underlying metadata to determine what type of area it is. The result is a look and feel that's all your own. And finally, you add your game. The map is just the foundation. Now you add the characters, landmarks, and interactions that drive gameplay. That's just a high-level overview, and now I want to use an example to dive a bit deeper into how you can use geodata to build real-world games and some of the considerations that you'll encounter as a developer. So for the purposes of this exercise, let's imagine that you want to build a real-world version of a resource-gathering game. So in this game, players will move around, collecting resources and claiming land and building kingdoms and forming alliances and so forth. The variations on this theme are infinite, and it lends itself well to a location-based gaming example because there's lots of different types of real-world data that you'll want to consider when you're building it. One of the very first things you'll want to do is link valuable resources, things like iron and wood and water, onto real-world locations like restaurants and schools and grocery stores. To do this, you need to understand what types of businesses are within reachable distance of the user. You'll also need to know properties of the businesses in a given area. For example, maybe you want to identify all of the real-world banks and allow your players to collect in-game currency at those locations. Or maybe you want to map a rare type of business to a rare resource. Maybe some treasures are so special that they can only be collected at a single landmark per city. And others are much more common, like collecting provisions at a grocery store. Maybe some resources move around, like herds of animals, and others are fixed in static locations. Let's say you've done that, and after linking real-world locations to in-game resources, you turn your attention to understanding how your game is driving foot traffic and how much foot traffic it's driving. You'll want to know where crowds will be so that you can generate more resources in crowded areas. Otherwise, the resources will dry up quickly and your game will be no fun. Your players can't progress. You'll want to understand how player behavior downtown is different from player behavior in the suburbs. And if your game is played all over the world, you'll probably need cloud analytics to find these patterns. How the game is being played at night versus in the day, in rain versus shine, or even in the northern versus the southern hemisphere. All of these things make a difference to your players. Once you find these patterns, though, you can adjust your game accordingly. For example, in Sydney, where the weather is perfect, it makes sense to place resources in parks. But in New York City, during the winter, you probably want to place resources in subway stations. Then, with a better understanding of how your game drives foot traffic, you could consider how to thoughtfully connect your players to the world around them, including the businesses, restaurants, and shops around them. Some businesses will be super eager to connect with your players, and they'll want to be featured as coal mines or collection points in your game. But other businesses, like hospitals, won't appreciate crowds near their entrances. To address this, you need a centralized catalog of the businesses around your users, all of them, all over the world. Pairing that with a good understanding of player behavior will enable you to evolve gameplay in a way that responds to the player's environment and results in a game that's fun for them and also fun for the businesses around them. Again, this is the essence of location intelligence. Contextual signals about the user's environment are used to enhance their experience. Okay, now let's talk about the map itself, the best part. The land, water, roads, and buildings that form the foundation of your game. In this case, the world is your game level, and the burden is on you, the developer, to understand it in enough detail to create a good game. If you accidentally place a valuable object in the middle of an industrial-scale garbage dump, someone is going to find a way to get to it. Creating a game that's both achievable and fun means knowing where you're incentivizing players to go, again, at global scale. You'll need to understand properties of the regions that each player is in. In the urban environment, you can use a unique building facade or building shape to orient a user. In the suburbs, you might use parks, and in rural areas, you'll need to use terrain and trails and paths to orient them. How do you design a single game that's exciting everywhere, no matter where your players are? In urban areas, you might use 3D building models or mark entrances to large businesses or display indoor maps. And remember, all of this needs to be performant enough to display on a smartphone. How should geography influence your game? Should items perched atop a hill or hidden in a dense forest be worth more than items placed at a busy convenience store? What about weather? Should players who venture out in the rain get more points than those who live in the always sunny Sydney? Probably. What about mode of travel? Should resource hunters on public transit get more points than resource hunters in cars? Or should the points be player-specific? Like, should you get more points for exploring the world further away from your home, or while you're on vacation, or more than 100 miles from where you work? Those were all static features of the map, but of course you'll probably want to make your game more engaging by incorporating real-time elements as well. And the possibilities here are really endless, but I'll just illustrate a few. So for example, as day transitions to night, maybe the look and feel of our game will shift. Maybe the game's night mode incentivizes a totally different set of behaviors. When most shops are closed, some streets are deserted, and people are sort of congregating around a few central points of interest. What about real-time events? You could attach special temporary resources to a parade or a game or another event. What kind of events are there? A concert. This is a way to make your game more social and more integrated with daily life. And of course, you'll also want to avoid sending users to businesses that are closed and down streets that are deserted. And you need real-time data to do both of those things. You'll also encounter lots of interesting challenges when you deploy this game in the wild. Users will try to spoof their locations. They'll pretend to be in many places at once and collect all possible resources, amassing giant fortunes and building castles that cannot be surpassed and just ruining the game for other players. You need to detect cheating and prevent it at a global scale. You need to place treasures carefully and make sure that you aren't incentivizing players to traipse into private property. You might also want to help players avoid busy traffic and understand where it's safe, appropriate, and even ideal to play games without having to verify each location manually. I hope that example helped highlight some of the ways that geodata, including location intelligence, real-time data, and the map itself, can be used to design a next-generation real-world game. Even this pretty simple and very generic example illustrates that there are endless ways to use geodata to make your game safer, more social, and more immersive. And by the way, I think lots of these apply to services outside of gaming as well. All mobile developers are pretty interested in making their services safer, more social, and more immersive. And we think that Google Maps data can help you do that at scale. When you design around the world, you get an experience that's unique and nuanced, no matter where your users are. And that's really powerful. And of course, when you deploy this in the wild, you need cloud analytics to inform gameplay and cloud infrastructure to support global rollouts. We're gearing up to see many more real-world games released this year. Game developers are beginning to approach us to understand how they can connect the real world to gameplay and how they can use location intelligence to build more immersive experiences. We think Google Maps is well positioned to power that connection, and we want to help. As games get more sophisticated, we'll see them leverage real-world data in new and inventive ways, including all of the things I just talked about. Those things will then become table stakes for the games that follow. We're excited to see developers use the new technologies that I touched on. Location precision and powerful smartphones are here to stay. And we're thrilled to see developers combine them with the new and emerging types of geodata that we can offer. So we want to work with game experts to discover new frontiers in this space. If you have ideas that combine base maps with dynamic place information in your game or application, come talk to us. We want to help developers leverage metadata about the base map to understand their player's environment, or connect players to the businesses around them, or provide 3D models to help them orient themselves. If you want to use aggregated movement data or other location intelligence signals to drive engagement, then let us know. We want to help developers understand how their players are moving in the world and how their game is ultimately being played. We also want to hear your ideas about how to use geodata to stop cheaters and build fraud detection into your games before you launch. If you have special requirements around analytics and infrastructure, definitely let us know. We're here to help developers analyze player behavior to improve the in-game experience. We can help crunch data and deliver insights that improve your game in real time. We don't want you to have to think about your infrastructure scaling, certainly, and we want to see global rollouts taking place seamlessly without downtime or anxiety. Finally, this one gets its own slide because I think it's really important. For a real-world game to go viral, it has to go global. And our phenomenal coverage makes that possible without manual data collection. We can provide 3D building coverage all over the world. Our places data set has details on 100 million places all across the world. What if your game could be played anywhere without spending hours of developers' time collecting and stitching together data sets? Believe us, we know how long that piece takes. Google Maps has been working for over a decade to provide a comprehensive model of the world with increasingly dynamic information. And we're excited to see how developers will combine the resources we provide to make the next generation of real-world games. At Google Maps, we're constantly working to make our model of the world more useful to developers. 13 years ago, we started with a simple web interface that could be panned and zoomed. Today, we help developers all over the world create experiences that connect users to our increasingly detailed model of the world in real time. We've already seen mobile maps revolutionize industries like exercise and ride-sharing and the constant hunt for good food. We're seeing more and more mobile apps use location intelligence to draw users in and keep them engaged. We're also seeing the real world augment apps, and apps augment the real world. And as that happens, the line is blurring between an immersive mobile app and a game. We're excited by these early examples that point to a paradigm shift in gaming as well, and we can't wait to see what new innovations game designers will bring to the industry. We're sure that game developers will use geodata in ways that make us rethink what we need to know about the real world to create a compelling experience. So in summary, if you're building a game that incorporates elements of geodata, come talk to us and tell us what you're trying to do. If you're building immersive mobile experiences that incorporate real-world elements, come talk to us as well. And if you see applications of next-generation geodata for your business outside of gaming, come talk to us. My team and I will be at the Maps Experts area today and all of tomorrow, immediately following this talk and also tomorrow. And I'm also going to invite a few of my team members up to the side of the stage right now to answer any questions that you may have, so feel free to come forward. Thank you for your time, and we hope to talk to you.